Good afternoon, everyone. Ani here. So as Samantha mentioned, I'm going to present process mining explained by a use case in the semiconductor domain. So today's presentation, I will go through what process mining is, process mining benefits, process mining algorithms, tools, use cases applied at ASML, one of the leaders in semiconductor industry, conclusion, and references. Well, starting, I want to tell about myself. I am Ani Megerdoumian, originally Armenian Iranian, currently based at Amsterdam. I hold PDN of professional doctorate in engineering and software technology from Eindhoven University of Technology. Maybe you wonder what PDN is. It is a postmaster program provided by 4 technical universities in the Netherlands. And the main focus, the second year, is a personal project, which in my case, I did my project at ASML, which is based in Veldhoven, Eindhoven. And today I'm going to give a case study that I did in my final project there. I have more than 6 years industrial experience and mainly in fintech, currently a software engineer at ING for a year now with a huge passion towards data. So, all right, let's get it started. What is process mining? Process is a collection of discrete activities or events performed in order to achieve a certain goal. One of the main people, which is known as to be a father of process mining, is Professor Wil van der Aalst, who was a professor in Technical University Eindhoven. Currently, he is in Aachen. By his definition, process mining is set of techniques used for obtaining knowledge and knowledge of and extracting insight from processes, and it's data-driven. So you have collection of the data, you have the logs, you analyze them, and end goal is to discover, model, monitor, and optimize the underlying processes. And process mining is considered as intersection between data science and management science, because management people can bring the processes into the picture, and data science people can have the statistics, analysis, collecting data, and so on and so forth, which might you guys know more. But how are processes modeled and represented? So I'm going to quickly tell you the ways that the process can be shown. One of the ways is PetriNet, or place transition networks, which shows piece and piece here, and it can show from one action the other action can achieve, and so on and so forth. And the next way is Gantt chart, which management people might know more about this. So it's a timeline, and the tasks are on a cascading order, shows the way they're proceeding, basically. And two newer way to show or represent or model the process are UML, known as Unified Model Languages, and specifically activity diagrams there, which we can show activity, conditions, forking and joining and starting and end of a whole process or activity there. And the other one is BPMN, which stands for Business Process Modeling Notation, which has event, activity, gateway, and connections there. And all of the combination here are serving to show the processes that are happening in this, into a specific system, environment, and etc. But what are the benefits of process mining, or what are the poles of process mining? Again, according to frontline people in process mining, first of all, it is process discovery. And basically what it is doing. So we are starting from event logs. The process mining techniques allow describing and modeling the actual processes that are being run in a system. And in the end, by process discovery, a model of the activities in a system are achieved. Second profit is conformance checking. And as you can see, with detailed documents, there are models which are already provided to any system. An application of process mining allows identifying their conformance. And with established compliant procedures. In this way, you have a model, you have an event log, and you want to check if it complies to the actual model, the as is of the system, like the logs of the system, which are already there. I will dive deeper into this. So if you have any questions, you can keep it in upcoming slides as well. The third pole is enhancement. So consider that now you have a diagnostics, and again, with the event logs and the model that you have, you already discover what are the bottlenecks in the system, what are the points in the system that are decreasing the throughput, like making processes late and latency. In other words, going one by one through all these three poles. So process discovery as the first one, I want to show you in a more graphic way. So consider that you have a data, that you have logs, and it is sorted by timestamps. So if you have some cases, per se, let's imagine a banking domain here. So you have a customer, which is your case one, and in this picture is depicted as a green rose here. So this customer or case one is doing activity A and then B, C, D, and E per time. And if you want to do the same analysis, it can be depicted as A, B, C, D, and E, and so on and so forth with case two and case three. So if you want to see the one model and what is the process discovery, you need to come across one network, one modeling tool, which can be BPMN, as I showed to you, etc. So you can see like all the cases started with A, and all of them finished with E and with D. So this action is called process discovery. Basically, you discover what are the sequences of actions happening in your system. And the second one, conformance checking. This picture might be familiar for people, especially people who are living in Netherlands. And in pavements, so many times you see that there are poles put here, and it is designated for pedestrians to pass through it. So if you consider in the literature of process mining, this can be a model which expect users to not pass by the bikes, but walk through these poles. But in reality, you see the grosses here are putting a path. So reality, you can say, okay, this is deviation from what model we have. So conformance checking in real life, it is doing some checks like this, like what we have as a model, and in reality, because we have the logs there, what we are achieving there. And in other schematic view, if I want to tell what exactly process mining concludes, let's start with the logs in a center of this picture. So as I said, process mining is data driven, and everything starts with event logs. So event logs, as I said, we can go through, discover the processes there. So we can have via some algorithm that I will go through them quickly in this presentation as well. We discover the processes, and from that, this is as is, because it's exactly coming from the event log. Then by applying some performance mining, we can go through performance charts and how the system is actually doing per se. Some process might take longer, some process might not be faster, etc., so on and so forth. And in the other hand, business people or experts of any system can come to the picture and bring the business rules there. And by this 2B process mining or ideal way, as I depicted the previous slide, like in a pavement, we can compare with the actual activity that the user is doing, and this is called conformance checking. And from conformance checking, with respect to event log prime, which is another set of logs, we can come across the differences, deviations, diagnosis, and etc. So this whole picture depicts what process mining can serve to any system or any domain. So what information is needed? Basically, for any sort of data related process, we need preparing the data. So in our case, it is logs. But how exactly, what exact fields we need to apply process mining? There are, again, 3 poles here, which you might already guess about it. So first of all is a case ID, which is a unique identifier of an entity going through the process. What does this mean? In a hospital example, the case ID can be a patient going check into hospital, going to specific diagnostic, going to I don't know, drugstore, etc., etc. So a unique identifier, and in bank it can be a customer, which customer ID isn't unique enough. And an event, which is the sequence of activity or processes that we want to analyze on top of it. Again, it can be opening an account, depositing, or in a, again, hospital case, it will be every single action that a case or a patient can perform. And of course, once we are talking about processes, time or sequence of the actions come to the picture, which is the timestamp, or if we are not sure that we have the exact time of performing a specific activity there, at least we need to know the sequence of actions there. I want to talk a little bit about the algorithms of process mining in the next topic that I want to talk. So these algorithms, like any other machine learning or artificial intelligence algorithms, they are processing or they're analyzing a set of data and they're producing some output out of it. And because in this field, most of these algorithms are called basically miners. So alpha miner, which is one of the oldest miners, basically for all of these, more or less, they are getting the log files, which have the specific qualities specified, these 3 poles that I already mentioned in previous slide, as an input. But as an output, alpha miner produces PetriNet with initial and final marking. So it says that this set of actions started with this process or activity and ends with that specific activity. And frequency of the event, which specifically mentions like 50% or this number out of the total cases followed this specific path. When we use alpha miner, it always generates results. So you can always use it, but it's not promising that it will always give a good result, but at least it will give good insights from for the log existing. Heuristic miner is another and more advanced miner, which as an output, it produces heuristic net, and again, it can be converted to the PetriNets. This algorithm, with the way it has, it can be used for the cases that we have too many cases. So in real life logs, whenever we have different events, we can use heuristic miner, and it can exclude the noises and abstract it in a better way that decrease the complexity of any system. And the fuzzy miner, as the name comes in, it produces fuzzy model, and it is good for, it uses significant correlation metrics to interactively simplify the process as desired level of abstraction. It is one of the newest algorithms, just emerged in 2007. And the fuzzy model cannot be converted to other types of processes like the previous algorithms that I mentioned. But the best thing about fuzzy model is that you can animate through it. So you can see actually how logs are flowing. For process models, like any other data science-related models, that we have some metrics for evaluating how good an algorithm is behaving. We have the same criteria, more or less, but in different, it looks at the problem in a different perspective. Remember what I mean by precision, recall, accuracy, etc. So the metrics in processes, in process modeling, can come across fitness, which quantifies the extent to which the discovered model can be accurately reproduce the cases recorded in a log. Precision shows the proportion of the behavior represented by the model, which is not seen in the event log. Generalization assess the extent to which the model will be able to reproduce future behavior of the processes and can be seen as measure of confidence in the precision, basically. And structure or just simplicity of the model captures the complexity of a process model in terms of readability. So how readable any model is. An argument point, we can argue that we can say for each event log, there is just one process model, just one best process model, but this is not true. Because again, likewise, the per se clustering algorithm, one can say, okay, k-means here X better, or I don't know, BPM, other algorithms can perform better, but it depends on the we use different modeling language, different mining algorithm, and different levels of accuracy. So you cannot say that the model is always the best. It depends on these views. But going to the tools for the process mining. So we don't want to reinvent the wheel. There are already good libraries that you can actually use is for your logs and your systems if you want to apply process mining. And I know Python as one of the most used languages, library called process mining for Python, which is PM4PY, which is a basic lib, is an open source. And recently, in the recent 1-2 years, the group has started to build Flask integration as well, which is I think it's with a little bit of a payment you can get the libraries. In R lovers, we have process map R within the VPAR packages. And software that actually I used, and it is intended more in academic usages, and it's free, and it's written based on Java. It is called ProM, and it is produced initially by, again, Technical University of Eindhoven under supervision of Professor van der Alst. And the interesting part about this tool is like for each academic purposes, you can add a new component, which each component can have new algorithm implemented, but it has already too many algorithms implemented. So you can simply download it, install it, and play around with your logs. And then the spin-off of ProM, which is Disco, abbreviation by Discovery, by Fluxicon, which is a commercial version of sort of ProM. And again, with a highly supervision of scientists, which have process mining experience. So again, I think you can use it free trial for smaller data sets, and it's commercial. And for all of these tools and libraries, the input is simply CSV files or XES format file, which XES recently became is an XML-based language, extensible event stream, and recently became as a main tool, main format for process logs, basically. And next, I want to go for the use case. So at ASML, which is one of the biggest and market leaders in semiconductor industry, which is a Dutch company, as you can see, TwinScan is one of the oldest, most important, and biggest machines there. And from the name, it has a twin, like 2 stages, which a wafer, which as you can see, circular plates come here. In for one side is a measure side, and the other side is an exposure side. And measurements are done, and then the plate or the wafer is transferred to the other stage, and the image is exposed on top of it. This is a really simplified version of what is going on there, but the components basically there is, as you can see in this diagram. And because all the process there is automated and done by robotic eyes and robotic arms, and all sort of engineers are working at the same time to produce images reflecting a nanometer precision. Processes are really, really complicated. So it's not always complying to this cycle, because sometimes measurements can go back and forth. Long story short, by the running of whole machine, a single one of the logs which is generated is machine diagnostic log, which is a flat format file, is generated for the whole machine run. But this log file is unique enough to have a tag for each specific action on top. By action, I mean it can be starting of a measurement, starting of a exposure of the light, starting and ending, or a specific measurement amount there. So consider that the unique action here is the specific tag. So in this slide, you can see I deliberately blurred this, because these columns, you can consider it as not important columns, but you can have tags, you can have unique identifier for the case you have, and you can have a sequence. So this is the job of process miner or process scientists, who differentiate what hypothesis they want to achieve, and determine which columns should be these three poles that I've already mentioned. So in this case, the case ID is combination of wafer, which the circular plates you saw in the previous animation, and the job unique ID, which is the start of the action. So combination of these makes the case unique enough. And the tag would be the activity, and the sequence is a sequence number, because here we are talking about nanoseconds here. And the purpose here was, different purposes can be achieved by process mining. Like, what is the bottlenecks there? How is the machine behaving on the case of for errors, or for making a precise pictures, etc., etc. So initially with the ProM tool, I converted the CSV file to XCS. These screenshots are from the ProM tool. And then, as you can see, you specify exactly which columns are your case and which colors are your event, basically. So I specify it, and I did these steps, which are generic enough that for any other data or any other use cases can be used. So constructed event log with a lot of pre-processing, we get to a data frame that can be used for process mining. Inspected data, so ProM tool provides a good inspector for showing the number of cases, the number of activities, or even the chain of events. In my case, it was the tags or the activities that were happening one after each other, and you can see it has a good percentage how many times a specific thing happened after the other thing. And then I use the fuzzy model per se, and for a very small subset of the actions there, I come to a diagram like this. And I said in a previous slide that fuzzy model, I can animate it. So I'm going to show you the animation of the process that it is there. This is all done by ProM tool, as you can see. So it shows a start action and how the activities are going on. And as you can see, the thickness of the line shows the higher number of the process transits from one state, or in my case, from one tag to the other one. So this can give a good insight from any domain that you're working on. In continuation, so I talked about alpha miner. This can be one result of alpha miner, again, showing how the transition of the states were going on. And directly flow graphs are another way to show. And as you can see, it can even show the green ones are starting states, and the red ones are the states that are finished. So a job that started in a machine mostly starts with the specific tags. And again, here you see the frequency of actions that happened and thickness of the lines there. But I just want to say that in complex domains, this huge process graph that you see is just 1/40th of what is actually happening in the domain. So this way we can come across a better analysis and improving and figuring out the bottlenecks and improving the throughput, which in this case it is in the scale of nanoseconds. So, conclusion, process mining is a great chance to take control of your data and start making better decisions based on the facts, because we are coming from the data than the intuition. And it can help in any case, in any domain that you even cannot think about. So it's detecting issues, it strengthens the operations, it prioritizes cost-effective action. So you can see, like in a banking, in which sector or in which process place the most time is wasted or the most time is consumed. So you can suggest how you can improve it. Then you can reduce the throughput time and increase, in the end, customer satisfaction. By customer, you can even mention stakeholders, because like in ASML case, it is end customer, but the stakeholder might be even people who are working in the same team. And if I persuaded you enough to like process mining and go through it, as it is really trending for any businesses, I would suggest to go through this book by Professor van der Aalst, Process Mining, Data Science in Action. And there is a corresponding Coursera course by the same person, which himself is presenting about the details of algorithms and how you can be a process mining scientist, basically. So this was from myself. Thank you.